Hi, everyone. My name is Marco. I'm a Senior Manager of Product Management at AWS, specifically on AWS Global Accelerator. And today I'm excited to talk to you a little bit about the service and what we've been up to over the last year, both in terms of use cases that we're seeing, customers that have been using Global Accelerator, and we can talk about, and new features and capabilities that we've been launching in the last year. So in terms of agenda, we'll give you an overview of Global Accelerator, how to use it, what it does, some of the benefits. We'll dive into popular use cases and customer stories, and then we'll wrap up talking about how the last 12 months have been looking like in terms of new capabilities. Let's dive right in. Global Accelerator is a networking service, is part of the family of networking and edge services here at AWS. It aims at improving the availability and performance of your applications, especially those with a global reach. So where you have a user base that is global or spread across multiple geographies. It very simply sits between clients on the internet, and this could be devices, users on the internet in general, and your applications running on AWS. It's an edge service, so it's a global service running at the edge of the AWS network in our edge locations around the world, and it's really meant to expose and offer you the benefits of the Amazon global network that we've deployed over the years across the world. So talking about some of the key features of Global Accelerator. So from left to right, we start with static IP addresses. So we offer two IPv4 addresses that we associate to your accelerator. When you create an accelerator, you'll see them associated to your accelerator resource. These are addresses that are anycast from the AWS edge locations around the world, and by default, you get two IPv4 addresses from the Amazon pool. You can also bring your own IP address ranges, and we talk about it later. How you can achieve that, but you can also bring your own IP address ranges from your own on-premise deployment. The static IP addresses become your single entry point for your internet-facing traffic to your applications running on AWS. And this could be a single application load balancer or EC2 instance in a region, or multiple applications deployed across multiple regions and multiple geographies. So that's the first benefit, the static IP addresses. The second one is the performance improvement. And so you can get up to a 60% performance improvement, and we talk about different metrics and how you can measure that in a second. This is for internet traffic that targets your application load balancers, network load balancers, EC2 instances, or elastic IP endpoints in a single or multiple regions. The third benefit is traffic failover. So in case your application is unavailable in an availability zone or in a region, within 30 seconds from when the detection of your endpoint becoming unhealthy, Global Accelerator fails over new connections to the next closest endpoint, which could be in the same VPC or across the world in a different region. And this is time bounded, so it's not dependent and reliant on DNS and client caching configuration. And it's time bounded in 30 seconds. And the fourth benefit is that by offering static IPs, you really get to be able to add or remove endpoints in different availability zones and regions with no change to your client configuration or DNS configuration. All the traffic goes over the Amazon network, so the backbone, and is protected from DDoS attacks by AWS Shield. So this is a quick overview of our global footprint. So I mentioned you can put load balancers or EC2 instances in multiple regions. Currently, we support endpoints in 20 AWS regions. These are commercial regions outside of China. The AWS region table has the updated list. And Global Accelerator runs today in 83 points of presence in 73 cities across 38 countries. It's more or less, it's 1 or 2 points of presence per metropolitan area. By not doing caching, Global Accelerator has enough capacity in each city with a single or a maximum two edge locations, 2 points of presence per city. And our FAQ page has the latest list. So how does Global Accelerator work? Let's say you have internet clients, your users spread around the world, and you have your application deployed into AWS regions. Let's say you have 1 load balancer per region, each with its own IP address. Without Global Accelerator, you will use some kind of geo-based routing to send traffic over the public internet to the closest application. With Global Accelerator, you get static IPs, any cast from and announced via BGP from edge locations around the world. Your clients just talk to one of those IPs or one at a time. And Global Accelerator knows, based on the configuration that you set up, which one is the closest region where your application is running, and onboards the traffic onto the Amazon backbone. And so what you get is 50 to 60% better performance. And this could be latency, throughput. We talk about it shortly. The other benefit is, in case your application in one region goes down, within 30 seconds, we fill over new connections to the next available endpoint. 30 seconds from the moment, and endpoint becomes unhealthy. Couple of words on how endpoint selection happens. So once a new connection comes towards your Global Accelerator, Global Accelerator looks at different factors. Geo-proximity. So basically, from an edge location, we send traffic to the closest region. You have control over how our traffic is routed. We offer traffic dials and endpoint weights, and there are some good resources out there, the documentation and blog posts on exactly how these work. Application health. So we run health checks against your endpoints in different regions, and we're not going to send traffic to unhealthy endpoints. We always only send it to healthy endpoints. And client affinity. We talk about it in a second, but it basically allows you to send traffic to the same endpoint if you want to keep traffic going over different protocols or ports going to the same endpoint from the same client. A few words on the benefits of Global Accelerator. The first one is the availability improvement. So in green, you'll see the line of the network availability with Global Accelerator. In blue, is going direct over the public internet. So those drops, basically, this is just your traffic is subject to whatever is happening on the public internet. So it may be, some ISP in a certain country having a bad day, and you're subject to it if you go over the public internet. Instead, if your traffic goes over Global Accelerator and the Amazon backbone, you'll see more consistent high availability. There's network availability, and there is also what we offer in terms of fault-tolerant design that you get with Global Accelerator. So I mentioned you get 2 static IPs. These are isolated IPs to ensure that you get a higher fault tolerance for your application. So we always recommend you to use both of them in round robin, or we offer also a DNS name that points to both of them in round robin. So you can alias the DNS name you get with your accelerator and make sure that you use both of them. And the benefit here is that the static IPs are isolated both in terms of network equipment and logically, so that if there's any availability issue with one of them, the other one is likely not gonna suffer from it. In terms of performance improvement, these are just some numbers, and this is how we look at performance. We see, first by latency, up to 50% better, across continents, up to 34% within a continent. In terms of throughput, we see up to 60% better than direct across continents, 40% within the same continent geography, and jitter, which is the variation and how consistent performance is up to 58% across continents and 8% within a continent. And so really these are three different lenses that we use to look at latency, and there are certain ways that you can test them. And a quick way is to go to the speed comparison tool that address, and from your client, basically you will see performance with and without Global Accelerator going to different regions of AWS. And then there are different options that we recommend. So from the best one to the one that we ask you to avoid, the best option is really to send some amount of your user traffic to via Global Accelerator and directly to your endpoint, and use your own quality of service telemetry and system to measure the metrics that you care about. The second best option is using a third-party real user measurement. There are several out there. As long as they have thousands of probes, and these are real clients on the public internet, you get a somewhat accurate reflection of what your actual users will see. The third best option is using synthetic monitoring from data centers or co-location facilities. This is not ideal. We understand that there are plenty of providers out there, so it's also a valid option. And the one that we hear a lot of misconceptions at times is that testing from EC2 clients, you would not see as much of an improvement because EC2 to EC2 already for the most part goes over the Amazon network. And so sending traffic from EC2 clients to Global Accelerator and to an endpoint in EC2 is not going to give you much of a performance benefit. So clients on the public internet outside of AWS, that is your best option to measure performance. A few words on how to configure an accelerator. So this is how the structure of your accelerator will look like. Okay, so you get an accelerator with 2 static IPs, then you set up 1 to 10 different listeners, TCP or UDP, with different port ranges. This could be lists of ports, port ranges, an individual port. And then you associate endpoint groups. An endpoint group is effectively a region to each listener. And you can set up to 10 different regions, and in each region, in each endpoint group, you can set a single or multiple endpoints. This could be application load balancers, network load balancers, EC2 instances, and elastic IPs. This is the hierarchy that you can set up. In the console, you just go to the Global Accelerator console. Another tip is currently you need to be in the US West Oregon region. This is a temporary limitation. But in the future, we plan to address it. Global Accelerator is actually a global service, like COF from Torah 53. And so the console where you set it up is not necessarily the region where your endpoints need to be. So you have to go to Oregon, create accelerator, give it a name, set up a listener or multiple listeners, different ports and different protocols. You can set client affinity if you want to have that stateful source to destination connection. Then you set up different endpoint groups, single or multiple ones. And here you basically pick the region and then the traffic dial. The traffic dial, think of it as a volume knob to how much traffic you want to accept for the region from 0 to 100. By default, every endpoint group gets all the traffic that is supposed to go there based on latency. And in terms of health checks, you configure health checks in the console or API for EC2 instances and elastic IPs. But for ELB, so application load balancers, network load balancers, health checks, these are inherited from the load balancer configuration. An important note here is that we use Route 53 health checkers behind the scenes. So in your security groups or firewall rules, you want to open those to the Route 53 health checks, and that's the communication link to do that. In terms of endpoints, you will see all the endpoints for a certain type in your in the region. You select them, and then you create your accelerator. You have weights. These are actual weights that sum to 100% in the end. Once you provision your accelerator, you get the 2 static IPs. You get the DNS name that points to those, so you can use either or. And as a reminder, the static IP addresses are assigned to your accelerator for as long as the accelerator exists. So you can enable it or leave it disabled. You don't lose those addresses as long as you don't delete the accelerator. And you can use AM policies to prevent deletion in case you really want to make sure that you don't lose those static IP addresses. Now let's talk about some of the use cases and customer stories that we see. So these are just some of the names of the thousands of customers that use Global Accelerator today. If you go to our website, we have a page dedicated to all these customers. You can read more with case studies and videos about, basically with their stories. I want to dive into a few of these. So a popular use case is gaming, especially real-time multiplayer games. So when you have multiple players that play a real time, usually this is UDP-based traffic, and we have, you can think of some popular games that you might know. A customer that's been using this for a while is Joy City. They publish a case study, so you can look it up with us. They saw network timeouts reduced by 8 times. The network latency on average went down from 350 milliseconds to under 200 milliseconds, and that's an average of everything that they've seen. And they just started seeing fewer complaints from their players about lag and the overall quality of experience. And so this may look confusing, but basically in multiplayer games, you have these groups of players that you want to send and combine on a single EC2 instance, right? So with Global Accelerator, as long as you can use different ports to make sure that that you send clients to a different EC2 instance beyond Global Accelerator and use the static IPs and destination ports to get there. So you will see that all the clients here are going to the same static IP, and based on the port, you can use listener and port ranges to send groups of players to a specific session, a specific instance and port. Another use case is communications as a service, or voice over IP, video conferencing. There are three customers that, in particular, that have been using Global Accelerator for this: Intercom, 8x8, and Crazy Call. The architecture more or less looks always like this. So you have different callers or different devices that want to communicate to each other. They both talk to Global Accelerator, which drives the traffic over the global network to a media server running on EC2. And they may have session border controllers that pick the specific instance, and then Global Accelerator routes them to the specific media server. So there are different architectures that and implementations that the customers have been using. But overall, one of the benefits here is that a lot of these audio and video workloads run over UDP-based workloads like RTP or TCP-based like WebRTC. And so these are some protocols that are not traditional web HTTP workloads. And Global Accelerator, since it runs at TCP UDP level, allows you to run any of those over the Amazon Global Network and get those performance improvements. Another use case is advertising technology. With Trade Desk is an example of a customer that has been using us for a while for this. Here the benefits are both low latency, ad bidding or ad delivery, but also global traffic management. And this aspect of global traffic management is not necessarily, is not only applicable to advertising technology, but Trade Desk has been using us this way. They basically use Global Accelerator as this routing layer between the client directly and EC2 instances in the regions. In the majority of cases, customers use application load balancers or network load balancers. You may also decide to use Global Accelerator directly in front of EC2 and use the traffic dials and endpoint weights for some very basic routing policies. Trade Desk has been using us in front of EC2 in multiple regions and to guarantee equal load distribution to all their EC2 instances. If you decide to go the route and instead of putting a load balancer for directly EC2 beyond Global Accelerator, there is this blog post that we published last year around how to integrate all scaling group events with Global Accelerator via CloudWatch rules and Lambda functions to add and remove instances based on auto-scaling group events. So auto-scaling group has a scale in or scale out event, calls a CloudWatch rule, triggers Lambda function that calls the API of Global Accelerator. And that blog post explains it more in detail. This is another use case. This is more of a traditional, web traffic API workload. And New Relic, Skyscanner, and Lever have been using Global Accelerator to get their performance improvements. Skyscanner improved their response time by 98%. Lever reduced their application load times by more than 50%. And they really care about getting global static IPs, this global traffic management layer, and acceleration, so both throughput and first byte latency improvement to multiple regions. Other use cases that we've been seeing over the year, one of them is video ingest in media and entertainment. This is particularly useful for user-generated content. So users on the internet uploading video onto your application on AWS. Flow Player has been using Global Accelerator for this. Another one is on the financial services. Refinitiv was part of Thomson Reuters. They're using Global Accelerator both for multi-region traffic management, for fast time-bound deterministic failover, also for the disaster recovery setup. And the last one is IoT or retail use cases in which you want to allow list a small set of IPs in your client devices, and these devices may not always have great connectivity to the internet, or you do want to always rely on DNS resolution. And so PAR Technology, for example, they have point-of-sale devices in restaurants around the world, and they allow listed IP addresses of Global Accelerator, and behind the scenes, they might add or remove application endpoints in different regions without having to change their configuration in their clients. So these are some of the use cases. Now let's go over some of the feature launches that we've released over the last year. So this is a list. We'll go through them one by one. But starting last year, the first capability they wanted to focus on was making sure that we preserve the client IP, the source IP address of the client, all the way back to the endpoint. We've done this for application load balancers and EC2 instances. We'll explain in a second what this allows you to do, but this makes Global Accelerator transparent. So you get the benefits of Global Accelerator without having, network translation at the edge and any of that. So your IP address, the IP address of the client is untouched when the packet gets to your application. Then we work with Site-to-Site VPN to launch Accelerated Site-to-Site VPN in December. We then focus on CloudWatch metrics, bring your own IP, TCP termination at the edge. CloudFormation support, and recently the one-click console integration with ALB. I will go through them one by one. So client IP preservation. So by default, what happens if you use client IP preservation, which you get by default with ALB and EC2 endpoints, is that your clients, which is a source IP, in this case 1, 2, 3, 4, will talk to the Global Accelerator Static IP, in this case 5, 6, 7, 8. And what we do is we make sure that there are different layers of encapsulation, and we make sure that once the packet lands on the EC2 instance or the application load balancer in your VPC, the source IP of the client is untouched. So you still see 1, 2, 3, 4. And I'll dive into how we achieve this in a second. For the EC2 instance, we'll see the TCP UDP packet with 1, 2, 3, 4 as a source IP. And we work with application load balancer to include the source IP in the X-forwarded 4 header. So one of the benefits of this feature is that you can put both internal ALBs and private EC2 instances in your private VPC behind Global Accelerator without having to expose them, without having to associate public IPs to it. So Global Accelerator becomes the fixed entry point for your internet traffic going to the load balancer EC2 instances. So this allows you, in the CDN world, it is called, referred to often as origin cloaking, but this does allow you to have a single point of entry for your traffic. So all the traffic is protected by the AWS Shield, and it reaches the your VPC and your internal ALBs and EC2 instances. With Global Accelerator is the only public IP. A couple of words on how we preserve the client IP. So as I mentioned, there are different layers of encapsulation, but this is all transparent to you. Basically, traffic from the internet client lands on our edge locations. When we said we have different with 2 subnets, different network equipment for the 2 IP addresses. Then traffic goes to over the Amazon Global Network to a VPC, which is managed by Global Accelerator. It is transparent to you. And the elastic network interfaces between the Global Accelerator VPC and your VPC. We make sure that this traffic, which is encapsulated, lands on your VPC. At which point we decap the packets, and you see the exact packet as as Global Accelerator were not even in the picture. So the exact packet as it's coming from the internet client. So in the documentation, we talk more about the fact that we create elastic network interfaces in your VPC and how that works. But the only gotcha to keep in mind is that since you can keep yours ALB or EC2 endpoints, they could be internal, private, or public. We want to make sure that you're comfortable and you signal to us. You give us a signal that you're okay opening the VPC to the internet, and so we check that there is an internet gateway in your VPC when you attach an endpoint behind Global Accelerator. Again, the documentation talks about it more in detail. Then in December, we work with the Site-to-Site VPN team to launch Accelerated VPN. So when you go create a Site-to-Site VPN connection and you pick a transit gateway as the type of gateway, you have the option to enable acceleration. So this is a checkbox in the VPN console. What this does is it creates basically accelerators behind the scenes for each of those tunnels. And so you get the benefits of the Amazon network to route traffic from your branch or data center over the edge location, and then over the Amazon network back to the transit gateway in the region. This is fully managed, so you incur Global Accelerator charges, but you don't need to actually manage the accelerators. VPN does that heavy lifting for you, and we work together to enable that. More recently, we launched CloudWatch metrics. If you're familiar with the network load balancer metrics or the in general, the load balancing metrics. This should be familiar, should look familiar. So three metrics: the new flow count, the process bytes into your endpoints and out from your endpoints to the internet, and different dimensions that you can use to look at those metrics. So per accelerator, per listener, per endpoint group, per geography, both in terms of where the AWS regions are or the destination edge, the AWS edge that the clients users have been using, by protocol and by accelerator IP. These you get by default by using Global Accelerator. Bring your own IP. So we launched this feature, I think it was in February 2020. The process is fairly similar to the bring your own IP process that you get with EC2. These are different, two separate ways of bringing your. So it's a similar process, but two very different pools of IP addresses. What I mean is, with EC2, bring your own IP. You can bring your IP addresses to a specific region. You can get elastic IPs out of it. With Global Accelerator, you bring IP address ranges to AWS Global Accelerator specifically, and then we start announcing them from our edge locations via Anycast. So there is no conversion between the two at this point. So you can select one or two IP /24 IP ranges from your on-premise deployment. You provision them. We provision them for use with AWS. You locate them to Global Accelerator, and then you can start creating accelerators with static IPs taken from these two. So if you bring only one /24, each new accelerator will have one IP address /32 from the pool that you brought, and the other one is going to be from the Amazon pool. If you bring two /24s, each accelerator, you'll be able to pick the two addresses from each of those pools. And so we always want to maintain that fault isolation and that those network zones, so that basically the limitation is we don't allow you to take for the same accelerator 2 /32 IP addresses from the same /24. And again, this is for availability reasons. We have a blog post explaining how that looks like, and documentation goes in detail on how to achieve this. More recently, we launched TCP termination at the edge, and this works for ALB and EC2 endpoints today. These are basically TCP performance improvements to your TCP traffic that you get by default by using Global Accelerator. Since we enabled it, we observe up to 60% performance improvement, especially in throughput. There's a couple of things about how the feature looks like. So basically, TCP termination means that the connection establishment, the initial TCP handshake happens between the client and the Global Accelerator and Global Accelerator at the edge, and then we do a second TCP handshake between the edge and the region. There are a few improvements that we also added. One of them is we use Jumbo frames, which allow us to, over the Amazon network, to send and receive up to 6 times more data per packet. Another benefit is another improvement and optimization is that we fine-tune the receive side window and the buffers, again, to receive and buffer a larger amount of data. So this also drives better throughput. And we also use congestion windows still to send larger amount of data. And so the benefit that you will see is primarily on the throughput side. So for the ability to send more packets more data per packet. And again, you get this improvement for any TCP traffic on going to ALB or EC2 endpoints via Global Accelerator. Then we launched AWS CloudFormation templates. So this has been, if you automate your deployment via CloudFormation, now you can easily also deploy your global accelerator, your listeners, and your endpoint groups and the endpoints in it. I've added links to the different blog posts that we release for each of these features that go in greater detail into exactly how to implement this. This is just a snapshot of how the template looks like. And very recently, just a few weeks back, we worked with the load balancer, the application load balancing team to add again, a simple checkbox into the load balancer creation console to create an accelerator behind the scenes and attach the load balancer to it. So when you go create an application load balancer, in the first page of the wizard, you will see an add-on services option. You check it, you give a name to the accelerator, and then after you're done provisioning, after both the load balancer and the accelerator are done provisioning, in the integrated services tab, in your application load balancer console, you will see the name of the accelerator, the ARN, the DNS name, and the 2 IPv4 addresses that you get that you need to point your traffic to reach your load balancer and still get the benefits of Global Accelerator. These are just some resources to recap that you have at your disposal. Definitely the product webpage, the documentation. It's a great way we put everything that you need to know about how to use the service in documentation. So that's the go-to resource. If you have questions for us, always feel free to use the AWS forum. For the latest list of edge locations, our FAQ page, and support your region, the regional table. Another new resource that I want to make sure I mention is that we just created this self-guided introduction to Global Accelerator workshop. You see it guides you through how to create an accelerator, how to set up a single region, multi-region application with Global Accelerator, how to use client affinity, how to do the regional failover, how to use origin clocking and keep your load balancers or EC2 instances private, how to test performance, how to look at metrics and logging. So it is very comprehensive. It might take an hour or so, but if within your organization or even just for yourself, you want to really dive into how to use Global Accelerator in a safe environment, I highly recommend you follow this workshop, and that's the link. Yeah, that's it. So feel free to reach out to me, the email or on Twitter. The forum is definitely the best way to ask questions so that everybody gets a visibility into your ask, and we all benefit from it. But yeah, I hope you get something out of it. Hope you learn different use cases and learn more about what's up and what's the latest with Global Accelerator. And yeah, thanks for listening.